Okay, so this is my lesson for week 6, lesson 6. We're going to be solving equations that involve logs. So in your previous lessons, you have learned how to condense logs. And that's what's going to be necessary to solve these problems. So like on example 1, if you're looking really close, there's 1, 2, 3 logs. And this is just nasty looking. It would look a little bit better if maybe there was only 2 logs. So what I'm going to do is over here on the left, I'm going to condense those 2 logs because I know the rules for that, and it would end up being log base 2 of x over 5, right? I've condensed the left, and then I'll leave the right alone. And then if you've got log base 2 of something equal to log base 2 of something, those 2 somethings have to equal each other. And so that way I'm able to solve this equation. And the easiest way to do that in this particular case is to cross multiply. 5 times 25 is 125, and that would be your answer. Okay, so let's scoot it up and try another one. Okay, so again, on this one, this original problem has 3 logs. It would be a lot nicer if there was only 2 logs, or maybe even only 1 log. So I'm going to condense the left using the rules that I've previously learned. If this is held together with addition, then I should be able to multiply those arguments together. All right, so then once the log with the same base, right, and again, it only works if these are the same base, are set equal to each other, that means that these 2 arguments are equal to each other. So we get 4x plus 4 equal to 3x plus 5. Moving this 3x to that side and this positive 4 to that side, I end up with x equaling 1. Something I probably should have talked about on the last example, but I'm just going to talk about it now. Double check, just kind of make sure that the answer that you get doesn't produce any negative arguments. What I mean by that is let me erase some of this stuff here. If I happen to plug 1 in here, this entire argument is still positive. It becomes a 2. And if I plug 1 in here, this entire argument is 8, and it's positive, and that's okay. If you end up with a negative argument, you're not allowed to list that as one of your answers. Okay, so let me move this up. Let's try another one. All right, we're going to condense. The condensing rules still work when they're natural logs. All right, so condensing this side, I get the natural log, and these are going to get multiplied because of this addition. So 2x minus 6 equal to the natural log of x minus 10. So now, if I've got natural log of something equal to natural log of something, I can set those 2 somethings, or those 2 arguments, equal to each other. Excuse me. So then I move this x to that side and this negative 6 to that side, giving me x equals negative 4. All right, but now watch what happens. If I actually check this, if I try to plug it in here or here, it doesn't matter. If it gives me something negative, then there is no solution. So even though I did all this beautiful, gorgeous math, and I got this answer of negative 4, when I plug it in here or here, I end up with the natural log of a negative number, which is not possible. So the answer to this problem is actually no solution. Okay, so again, be really, really aware. No negative arguments. Make sure you check. Okay, so then let's take a look at this last example. Again, I'm going to condense the left because I've got 2 logs separated with an addition. Notice I don't have a base here, not that big of a deal, right? If it's not written there, it's understood to be base 10. Multiplying these 2 arguments, I get x squared plus x. Bringing down the rest of this equation, I get log 6. So now that I have a log on each side with the same base, I can set the arguments equal to each other. All right, now this is a quadratic equation, so I'm going to set it equal to 0 in order to solve. All right, this is factorable, so I'm going to factor it. All right, and you've solved lots of equations by factoring. You notice that each of these factors equal to 0. So I get x equals negative 3 on the first factor and x equals 2 on the second factor. But again, notice if I put this -3 here, right, back into the original equation, if I put it right there, I get a negative argument. This answer doesn't work, but the 2 does. So the entire answer here is just x equals 2.